Good morning, evening, afternoon, everyone. Thank you all for joining us live or on demand. We hope that you're all having a great week so far, and that you really enjoyed the holiday weekend that we just had. My name is Brandon Rees, Product Marketing Manager here at EMQ. And today, my colleague, Ernest Russell, who's our Technical Content Manager, and I are really excited to talk to you about navigating digital transformation and where things like AI, ML, and digital twinning really come into play. Before we get started, some quick housekeeping items. Today's webinar will include a 15-minute Q&A session at the end. So we ask that you please use the Q&A tab at the bottom of your screens to submit your questions live. And we'll be sure to answer them and field them at the end. We'll try our best to answer them. If for whatever reason we're not able to live, we will fetch those answers for you internally, and we will get back to you promptly. And lastly, a recording of today's session and a copy of the slide deck will be shared with you after the webinar. So expect to see that shortly after as well. Next slide, please, Ernest. So today, here are the different things that we'd like to cover and talk about. So starting first and foremost with digital transformation, we'll give you information as to what it is and ultimately why it's important, followed by an introduction to MQTT, what it is, what are its strengths, and how does it help with overall digital transformation. Then covering and moving on to the evolution of ISA 95, which Ernest will cover in greater detail, but I'm sure you've seen the pyramid. And then with Industry 4.0 and the concept of unified namespace, and closing with unified namespace and how MQTT helps supplement and make it even better. So let's go ahead and jump into it. So to kick things off, really wanted to be able to speak to some primary digital transformation concepts, right? And there's three that really stand out. So top to bottom, digital twinning, machine learning, and artificial intelligence. Starting with digital twinning, I'm sure you've heard of it before. It has been a phrase that has been coined for some time now. But looking at the illustration here, tried our best to paint that picture. It's basically exactly like it sounds, right? You're digitizing a physical device and making a virtual digital representation of that exists in the cloud. And the values of that, right? There's many. So everything that you see on the physical device, whether it's sensors, readings, it removes the need for you to be on site, right? And have those folks tending to the machine there in person. Now you'll be able to look at these things in a virtual landscape and be able to more proactively work and make changes as needed. So a lot of value that comes through digital twinning. For machine learning, another concept I know everyone is quite familiar with, but just in case you're not, it is a subset of artificial intelligence. And it really is AI that focuses on the development of things like algorithms and statistical models. And these are often trained against large data sets that really allows them to identify patterns and make predictions and ultimately optimize that performance. And for artificial intelligence, which is the hot buzzword in the industry now, right? I know most people are familiar with it in the ways of ChatGPT and other bots of that fashion. But what we're talking about here is how AI is essentially meant to simulate human intelligence in machines, right? So it really is looking to augment and take on tasks that were typically led and managed by humans. So again, all of these different things together, when you combine them, will make a more seamless experience on the manufacturing floors or wherever you're implementing these technologies. Next slide, please, Ernest. So now the next question is, why digitally transform, right? And again, there's a lot of key reasons as to why we should do this, but kind of revisiting what I mentioned before. So by having those digital representations of your products, right, you're able to get more real-time visibility into their operations. So, if you set things like thresholds, like, oh, if this machine goes over a certain temperature or it applies too much pressure, right? You can set a routine or rules to stop operation that may result in huge loss in revenue or downtime and things like that. But the ultimate goal here is to apply those technologies and be able to look at how do I build a better mousetrap, right? And how do I visualize that in the data, right? So by digitizing and actually having everything in one place, that becomes easier to do, right? You're able to draw those common threads more simply and be able to I quickly identify ways that you can further enhance products. So the other one is making informed decisions and ultimately data driven. So rather than just taking guesses, oh, I think production is slowing because of area A, right? No, now you'll actually have the data you can do, and Ernest will go into a lot of this in much finer detail. But you will be able to search very targeted, right, at other aspects of the business, and you will have operational data to back your decisions instead of you just taking a shot in the dark. So know that there will be value that come from those data-led decisions. Another reason why you should digitally transform is because ultimately you want to stay competitive with your peers and competitors in the space, right? And this in and of itself was an example of the industrial revolution, right? When we first started in 3.0, which we'll go into later in the presentation, the US was slow to jump onto 4.0. And because of that, there was a chunk of time where we as a nation fell behind, right? So it's better to adopt these technologies early when the iron's hot and to make the most of it, right? So don't be left behind and stay competitive in the market. And by introducing and implementing everything we talked about so far, digitization, leveraging things like AI and ML, the goal is to improve the overall customer experience, right? So in this case, we're talking about the employees that are working those manufacturing floors, right? So how do we better equip them to have a more seamless experience, more effective, right? And by letting them have things like real-time data visibility to make those more informed decisions and to reduce things like downtime and just overall optimization, they're going to be happier. The business is going to be happier, and ultimately the business will be more successful. Next slide, please. So that leads us to some of the key challenges that we see with digital transformation. First and foremost, the interoperation between different devices, sensors, and protocols. So as you can imagine, on a manufacturing floor, right, on a huge site, there's different functions, different machines in every single area within these different facilities, right? So you bet that you need to be able to have a solution that's agnostic to not only device, right? So whether you're talking about a robotic arm talking to an assembly line, conveyor belt, a paint machine, a heat press, right? There's a lot of different functions going on. So it's not always the easiest thing to tether those things together so they can seamlessly communicate and work as one. Um, Device type aside, also have to think about protocols, right? There are a plethora of different protocols out there today. And we at EMQ, we do support a lot of them, and we'll get more into that later. But it's quite difficult to, and it can be it can be a deterrent to folks like, oh, there's too many moving parts. I don't know if I can implement these solutions, right? And we're here to tell you that's not a problem. There are ways around it to help tie those things together in an effective way. Another is data silos. So try to illustrate it there on the right-hand side. So with all of these different functions within a work site, right, in a manufacturing plant, like I mentioned, it could be siloed by device functions. So robotic arms can have its own. If you're feeding into an ERP system, feeding into a MES system, there's many different ways you can slice and dice how this data is being kind of packaged and warehoused. But really need to be able to break down those barriers and just have an open data set where everyone is sharing and has the same view, right? Which Ernest will cover in the following slides. And the other aspect is managing large amounts of data and ultimately scalability, right? So that's where MQTT is going to come into play. And so what I can say there is as you're scaling and making these connections, traditionally, if you're not using MQTT, you will have those constant, consistent connections, right? And a lot of these machines are outputting very repetitive sets of data, right? So you got to ask yourself, is there really a need for me to say, oh, this robotic arm is putting out 50 pounds of pressure every second, right? And the answer is probably not, right? So how do we streamline that process, make it more efficient, and only be notified when there's a notable change, right, that we can act on and to make a difference. So getting around that hurdle is another big challenge that we ultimately see in the space. And with that, I would like to hand things over to Ernest to tell you a little bit more about MQTT.
Thanks, Brandon. That was a good introduction to get us set up here and going. We have had the pleasure of visiting a lot of conferences this year. Um, and the key concept in a few of those has been digital transformation. So we've been talking to leaders in this space, digital transformation officers, and these are some of the key challenges that bubbled up technology wise. There's one that isn't here, and that's the people and the culture, right? And to help foster that culture of innovation and change as we go through this transformation. So we won't talk so much about the people and the culture, but again, those technology steps that we can take to help you in that transformation. So the first thing I'll talk about here is our form of unification in the MQTT protocol, right? How do we get our devices, our sensors speaking the same language? MQTT has become the premier language or protocol for IoT workflows for several reasons. One is the publish subscribe model is very efficient, very resource efficient, not just with memory, CPU, and even storage, but more importantly, bandwidth. Originally, MQTT was designed by Dr. Andy Stanford Clark and Arlen Nipper in the 90s, and it was created to monitor ConocoPhillips oil pipeline. And as you can imagine, there wasn't very good connectivity, and the connectivity that was there was satellite, Viasat, and that bandwidth comes at a premium. And so it was from the start, it was designed to be very bandwidth efficient, um, resource efficient, highly scalable, and I want to mention the quality of service levels because this is part of what gives you granular control over your IoT workflow. So in MQTT, there are three quality of service levels. Zero is what we call fire and forget, right? We send the message and we don't wait for a confirmation or acknowledgement that that message was received. And as Brandon mentioned, when you have values that don't change a lot or that don't need constant updating or a couple seconds is okay, then QoS 0 is okay. It is a real-time protocol, so we can achieve messaging and sub-second messaging. So milliseconds, even with millions of devices connected. So that's QoS 0. QoS 1 would be at least once, where so in that case we're going to keep sending the message until we get an acknowledgement, which can result in duplicate messages. QoS 2 will deduplicate. So that will send at most once. So we'll send until we get an acknowledgement. And then there's some deduplication built in to make sure that that command, that message is only received once by the client. And the last thing that I'd like to mention here is the connection loss awareness. So when clients, whether that be a publisher or a subscriber, goes away, we are aware of that through the MQTT protocol. We have a feature built into the protocol called the last will message, and that is established when the client connects. And in the same way that as people, we create a will to determine what we want to happen and in our passing. I mean, it's the same thing for the client. The client determines what message or what it wants to happen when it goes offline. So you can send a message, we can set some type of trigger or alarm for an action to happen. So again, MQTT protocol has, for these reasons, has become the premier IoT protocol, and we'll see as we go further how that relates to your digital transformation efforts. So I'll start here on the left with some of you may be familiar with ISA 95 or International Society of Automation Standard 95. And this standard was brought into place this was one of the first steps to that digital transformation, understanding that all of these things in that IoT world, Internet of Things, need to be connected, from sensors and as Brandon mentioned, robotic arms, sprayers, manufacturing lines, manufacturing equipment, these all need to be connected. So at the bottom level there, level 0, that's your production floor. That's your warehouse. That's your manufacturing facility. And then we have PLCs for sensing and manipulation. And typically those were controlled by SCADA systems. So we usually have a good number of SCADA devices within these production environments that need to be managed. And then we have our manufacturing execution systems and our business and planning logistics systems that sit on top of that. And what I'll bring this to your attention on the left here, that when we talk about those sensors and robotic arms, those commands are coming in constantly, every second, again, and even sometimes in every few milliseconds. So how do we reduce this time of milliseconds, seconds, minutes, hours to the days and months of that business planning and logistics? So when we look at that ISA 95 architecture, again, it was a great framework to get us started understanding that a key part to digital transformation is that connectivity, is being able to get information from our sensors, from our robotics in real time. But this framework is somewhat flawed when it comes to scaling, because these are point-to-point systems. And when we start to connect everything in that full mesh architecture, it doesn't scale very well. And also, when we need to replace one of these levels or one of the blocks in this pyramid, it becomes quite a task to be able to go in a modular fashion and replace that. that solution. And so I'll point out to the right here an evolution of that. And using MQTT, you can see our broker here in the middle acts as a middleman to accept all that data and deliver it to cloud systems. So in that publish subscribe model, there's a decoupling of everything of your devices and the cloud, with at the same time keeping connectivity. So what that means is everything does not need to connect to everything. It talks to our broker, and that broker, that MQTT broker, has the intelligence to know where these messages should be routed, and subscribers to this data can go in and access that data in real time. And when we talked about different protocols, right? So you may have changed equipment at some point. Maybe you acquired another business that uses equipment of a different protocol. Maybe it's a proprietary protocol. So the first step in that digital transformation is to get your equipment talking in the same language, and that's what we're seeing here with these gateways, Sparkplug enabled gateways that connect to your sensors, connect to your PLCs, connect to Modbus devices, pull in that data, and communicate using the MQTT, the very efficient MQTT protocol, to deliver that to your business systems, your cloud systems. And this is extremely important when we talk about digital transformation, because in order to use AI, artificial intelligence, in order to use machine learning and training algorithms, in order to build digital twins, the first requirement is making sure that you have access to the data, and even more so, not just access to the data, you want that data to be accessible in the same place. And when we say the same place, that doesn't always mean physically, and that's where the concept of unified namespace comes in, because it's logically represented as data living in one place. But it could be in the cloud, it could be in your data center, it could be a hybrid of that. But we want that data to be accessible by our backend systems. So here's an illustration of when we talked about Industry 4.0 and ISA 95. Again, you can see all of these systems need to be connected, right? Our management systems, our SCADA systems, our PLCs, all of these things need to be connected. But you can see as we add more devices and more systems, it becomes data spaghetti, hard to manage, hard to scale. That concept of unified namespace, with an MQTT broker facilitating that, again, decouples each one of these systems from having to connect all to each other. All they need now is one connection to the data broker, or in this case, our MQTT broker itself. And we'll show you how that helps facilitate unified namespace. But also, we want to be able to do that in an efficient manner. So one of the ways that we help do that is by building an event-driven architecture. What does that mean? That means reporting based on events, reporting by exception only, right? Because as Brandon mentioned, we PLC values, especially in most cases, don't fluctuate very much. They usually stay within that operating range. So let's use the example of temperature, right? We may not need to be notified if that is within, let's say, the normal operating range of 70 to 80 degrees, right? That's normal. But what if we get to 100 degrees, right? We may want to notify an engineer. We may want to send a control command to turn off a pump, to turn on a sensor, to open a valve. And so based on that event, we can trigger certain things to happen. And you can see here in this illustration, the idea of that publish subscribe or pub sub model, as we refer to it, where there's something, right? The event data that happens at the source, and this is your sensors, this is your PLCs. That would be your publisher. So that publisher will talk to an MQTT broker, which will route data depending on what that application needs. So that's called a subscriber. This is a two-way communication. So clients can be subscribers and publishers. So again, very granular control of your workflow and your data flow from that shop floor, manufacturing floor, all the way to the cloud, your backend databases, your AI systems, your machine learning algorithms. That's where this would sit. So again, that awareness of MQTT with the last will feature that I mentioned helps to make sure that you are receiving the latest messages, that you're avoiding stale data, because if that client goes away, if those readings are out of time, you will be notified. So again, with MQTT being highly efficient and building this event-driven workflow, it helps to really manage that data, large amounts of data, as our devices grow, as we scale to support thousands and even millions of devices. And I will say that our broker can support millions of devices and still achieve sub-second latency. So let's dig further into UNS, Unified Namespace, and how MQTT helps facilitate that. On the left here is a representation of where your data lives, right? And the point of this is we want to make it, for one, human readable and human accessible, even though these tie into cloud systems, databases, to AI training or machine learning, AI systems, AI plugins. We want it to be represented logically for a human. And so you can see here data represented in a folder hierarchy where there's edge nodes, your enterprise A location, site A within that enterprise location, area within that site, and a process. And then below that, you may have different devices. So, and all of that has not just your data, but what we call metadata, right? And metadata is data that describes the data. So that becomes very important as you're collecting so much information for that data to be described properly. So you can see here that data coming in, and MQTT being able to filter and deliver that data to your subscribers, to your backend systems. And so what this represents um, is again that granularity of your data being accessible from one place, but also accessible in a highly efficient manner, easy to find. At the bottom here, you'll see what we call an MQTT topic. And in the same fashion as we have the folder structure here is it's very human readable, right? Easy to understand. And this is called an MQTT topic. And each level is separated by a slash here. So we see we have namespace, group ID, message type, edge node ID. So on your backend systems are able to go directly to the data needed. You're able to filter that data and even create rules. Our MQTT broker has a built-in rules engine to allow you to set alarms, certain triggers, and again, build that event-based architecture. Actually, our Neuron EX also has that feature of a rules engine. So as you're doing that data transformation to get your devices talking the same language, you can apply rules and filters to that to have that data where you want, how you want. Speaking of Neuron EX, a Neuron EX is we have a new release of this, and Neuron EX, you might be familiar with Neuron. Neuron EX adds some additional streaming features from eKuiper um, to to help facilitate that IoT platform, right? All you need to get your data from that shop floor, from the sensors. And here, this is not an all-inclusive list, but you can see some of the protocols that Neuron EX translates right out the box. Modbus, OPC UA, Mitsubishi, Schneider Electric, Siemens. So we have that functionality built in, those translators for you, and you're able to download, add modules as needed to add functionality to that translation or to translate from other proprietary protocols. So Neuron EX definitely helps to eliminate those data silos we talked about because it tackles that challenge of how do we bring all these diverse devices and equipment, how do we bring that data into one place, into a unified namespace where it's accessible for, again, our AI systems, our time series databases, our cloud processing services, our apps. So, and the Neuron EX, again, has a built-in rule engine and also supports AI plugins. So, allowing you to use those plugins to make maybe make automated decisions that usually at some point that a human had to make or somebody had to go down to the shop floor to read that data from the sensors and make some kind of decision. Um, so definitely helps with that automation. We'll see how that looks in the bigger picture shortly here. So here's a good example of the connectivity. I want to show you the big picture of what this looks like in your network, what this looks like at your site. So on the left here would represent a again your edge devices, your sensors, your manufacturing floor, and typically that was operations technology. right? And operations and IT have traditionally been separated. But as we continue this digital transformation, we're seeing more of a marriage between those two, between operations and IT. So that's what we're seeing here with your sensors, your devices connecting to an edge broker on site. And what that allows is MQTT is very bandwidth efficient, but we can make it even more efficient by making rules, filtering that data at the edge. We may not need all of the data in the cloud, all of the data in your backend systems. So being able to filter and send only the data that you need may save some money also, right? Because that's where the cost comes in, is not just having data in the cloud, but as we move data in and out of the cloud, that's when your costs start to add up. So we're seeing your operations technology here. This network block in the center just shows our flexibility of being able to communicate over the MQTT protocol over different types of data networks. Everything from, I mentioned satellite to 4G, 5G, wireless networks, IPv4, IPv6. It can even be used over UDP using the QUIC protocol. And of course, we have plugins that will allow you to communicate with WebSockets. So if you're talking to an app or talking to a browser, most likely you'll be using WebSockets. So very flexible in how we can connect your edge devices to the cloud. Basically, any type of network that we can use. And then we have this third block represents our unified namespace cloud, right? So this is where all of your data lives, routed and managed by that MQTT broker, bringing in that data from your edge, from operations into that IT infrastructure. So again, this is where your AI services would sit, your backend databases, your applications, your thank you for the questions, and yeah, we'll make sure we get to those right after the session. And again, if we don't get to answer those, we'll make sure we get back to you by email. So thank you. Don't forget to use the Q&A. All right, so now let's dig a level deeper with actually one of our client workflows. This is a very large water processing plant that we helped design a solution for that includes both AI and digital twins. So on the left here, we can see represented our water meters, our sensors, smart terminals, and some of these communicate in different ways. Co-op, machine-to-machine language, some HTTP, WebSocket, but we can help with that translation, bringing in that MQTT data into our broker. And you can see with our Neuron EX, it again, all of those different devices, all of those different SCADA devices, PLCs, we're able to do that translation, send that into our rules engine. So you can take advantage of that event-based architecture and feed that data into that MQTT broker, which in turn routes that into the different platforms. You can see at the top here a BIM or Unity 3D system for visualization, right? So everything from just a simple dashboard to augmented reality and virtual reality. So providing real-time presentation with real data. So you're seeing a visual representation of what's going on your shop floor in real time. Also, that data interaction. So not just being able to see or access that data, but being able to interact with devices. Since MQTT is that two-way protocol, we can publish and subscribe. We can we can send commands back to these devices also. So things like over-the-air updates, things like turning a valve, a meter on or off. We're able to achieve that and interact with that data through MQTT. And also, this is where your AI data models will live. So again, presenting that data in a unified architecture, you're able to look at that, or I should say, is able to look at that on a much larger scale than a human would, right? And be able to realize patterns that we may not see over time. And so that's where prediction comes in to be able to predict certain failures, be able to help facilitate maintenance tasks, and make sure that those are being done in a timely manner to prevent failure. So it really does help with reliability and uptime, which is more and more important in these IoT workflows. Can you afford downtime? Can you afford for that equipment to stop? Right? Usually we can't. So um, again, this is a real use case. One of our customers. So just wanted to highlight that and show you that a real example of that digital transformation. And this facility went from a water processing facility to a smart facility, and all of those meters, sensors did not have to be replaced. These were legacy devices that we were able to add functionality on top of with both our Neuron EX and our EMQX broker to be able to make this a smart system. So with that, I will wrap up and get ready to take some of your questions.
Yeah, thank you, Ernest, and thank you everyone for submitting your questions. Did share some links beforehand, but I do want to speak to them too. So the first question we had was, how is Neuron EX configured? And is there a graphical user interface or a versionable configuration file? And where's an overview of its features, things like OPC, UA subscriptions, registered reads, etc. Um, Speaking to that, I did share a link to our dedicated page that will cover a lot of that, as well as our dedicated documentation page that goes more on the technical side. Um, Ernest, did you want to speak to the graphical user interface portion?
Yes, many of our customers are using the GUI. It can also be configured and controlled by command line, but these systems, these IoT systems, we don't, as we merge operations and IT, we don't want it to be a steep learning curve, right? So these systems are very easy to launch. Actually. Even for our broker, we even have one-click deployment in Dockers and Kubernetes. So if you're launching containers into your cloud infrastructure, it's very easy to do that in a scalable manner. So plenty of flexibility in how you want to deploy, whether that's on premise, in the cloud, or a hybrid of the two.
Great. Thanks, Ernest. Another one was, are there protocols that EMQX or NeuronEX can't ingest, process, or forward? And if so, generally, how long does it take to weave in new protocols? So yes. So we do support, I would say, north of 100 both popular and proprietary protocols today. And those are, of course, as need and demand arise, right? We try to get ahead of the curve and give first support the ones that we thought would be of interest. But by no means is that a limitation, right? If there is a protocol that is not on the list that you need supported to be able to leverage this solution, please contact us. We would love to evaluate and be able to give you better timing on how we can piece that together. So yeah, please let us know if there's anything that we can add in. Um, did
Thanks.
see another one come
Yeah, I
in.
see Falk had a question here. So, and that's right along the lines of, as you were saying, Brandon. He's
Mhm.
asking, is there an extension to add protocols or data syncs,
Yep.
or do I work with MQTT clients, or how do I work with MQTT clients in that
Mhm.
case? Um, yes, it is very easy to add modules to add data syncs that we're solving the same problem over and over, right? Again, Mitsubishi, Siemens, a lot of these manufacturers and protocols, those that library is already there. However, if you need to add an additional system or data sync, it's very easy to do that, and that can be achieved through our data integration a lot of times with very little code and we have a full API that allows you to interact and add functionality to the broker.
Great. Another one was, and I know Ernest, you spoke on this a bit earlier in the presentation, but does EMQX have an AI services built into it?
Well, not our EMQX broker does not. We interact with AI systems through plugins and data integration. But actually, our testing tool, MQTTX, which is used to assimilate devices, we've used that to test 100 million connected devices and still achieve sub-second latency. So that does have Copilot integration built in. But the broker itself, you would need to connect to your AI systems through data integration.
Perfect. Another one was regarding UNS. So it says, what if they don't know exactly how they want their data to be mapped or represented in the UNS? And asking if there are templates that they can work with and work with our experts to consult with them. And the answer is there's no 100% cookie cutter implementation that's going to work for everybody, right? There will be templates that we can work from as a starting point as well. But when we look at the data itself, we logically try and funnel them to their designated areas today. So I think we have a good idea of where they should be, right? But as far as consultations, yes, working with us, we do have two support packages and plans that you can work with. Um, if you don't want to go through our community, which is a great source, we also do have a plan that does 5 days a week, 8 hours a day, or 24/7 coverage. So we do have professional services and experts available to help you through implementation if the need does arise.
Thanks, Brandon. And I'm I'm still impressed myself with the plethora of tutorials that we have available almost daily.
Yep.
We're writing new tutorials on how to connect our broker to your systems,
Hmm.
whether that's a Redis, whether that's a time series database, whether that's AI services. We probably have a blog or a tutorial already out there to help you. So as Brandon mentioned, between the forums and the blogs, there's a lot of self-serve help out there for you, but When it comes to enterprise scale, and when you're talking thousands or maybe even millions of devices, I would really suggest tapping into our experts. We have seen in some cases where there were some minor errors in configuration in configuring the system that did hurt performance. And so by consulting with our experts, we can help you help make sure that you design a system that works for you and that will continue to scale as your business grows.
Oh, great. Thank you, Ernest. This next one's a two-parter. Um, Number one, does the MQTT broker store all messages that are sent? So bookmark that one. And then the second half of that question is, since all communication is going through the MQTT broker, is it a single source of failure if it fails?
I'll tackle
Yeah.
the second question first, in that it is a highly available system. So our our brokers are deployed in clusters, usually with three core nodes, and then replicant nodes that are strategically placed. These replica nodes are constantly kept up to date, but this allows, for one, not a single source of failure, and two, rolling upgrades. So you don't have to take the system down in order to update your software. And by having a replicant node close to your edge devices, that latency, that performance is there. So we can make sure that you have that sub-second, that real-time latency that you require. Secondly, does the MQTT broker store all messages sent? No, it does not store all messages. There are messages that are queued locally to make sure that, let's say in the case where a client disconnects, right? There's session awareness, we called it, built in, so that if a client goes away and comes back, we actually recognize that device, recognize that session, and allow a seamless connection back to that device. And so all messages aren't stored at the broker locally, but what we are seeing many of our clients do is to send that data to a time series database. So that way, that becomes your historian, right? If you need to go back a couple days, a couple of months, all of those messages will be written to the database.
Great. And I see one more here. Actually, no, I stand mistaken.
A
From,
couple more.
yep. So the next one, how do you protect topic payloads from being published or overwritten by unwanted applications?
Well, we just like any, thanks for that question, Tom.
Yeah.
Just like any enterprise system that you would expect, there is authentication and authorization, right? So authentication is that, user password, making sure that you can connect securely, and then authorization, right, is the different levels that a client, whether that be a publisher or subscriber, has access to. And so you are able, at a granular level, to set those permissions on what topics can be published or overwritten. So gives you some enterprise level security.
Thank you, Tom. Another one from Falk. How do you enable clustering? And a client should be able only to connect to one IP, but which IP is this in a cluster load balancer?
I will. I'll tackle that one, Brandon. So, what we usually see is that a lot of times clients will place a load balancer in front of our broker. right? And so that allows several things. For one, it gives you that extra layer of protection because typically that behind that load balancer is your firewall, which translates those IP addresses into private IPs. So that way that data isn't routable directly, right? You have to go through a load balancer, and again that provides another layer of protection. And how do you enable clustering? Our 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 broker is deployed in what we call a mirror architecture, where again we're any of our clusters, unless you are just deploying a local cluster on a server on Raspberry Pi device, it doesn't take much resources. Um, in that case, clustering, won't be automatically enabled. But when you used our cloud services, those clustering is included. So you don't have to worry about that scalability, or if you're going to be able to support all of your devices as you continue to grow your IoT fleet.
And then just some popular load balancers that we recommend: HA Proxy and Jinx, which I'm sharing in the chat as well.
Oh, thanks, Brandon.
Of course. All right, I believe that are all the questions we have. I know we still have time, so if anyone had any other questions, please submit them now. I'll give you another minute or so. Um, any other things that in the meantime, Ernest, that announcements or things that we'd like to share um, in this
Yes,
podcast?
I'll take this time to add that again. Check out our website. Check out emqx.com. Plenty of tutorials, blogs. We do have this monthly webinar. We also have our developer group that hosts our office hour sessions, and so those will usually be a little bit more technical. Give you a chance to interact with our team, ask questions about your workflow, and these are for you. So we're always open to suggestions. We're always attending events and conferences to hear your challenges and see how MQTT and our broker can help resolve those.
Oh, great. Thank you. And one last thing, just in the interest of privacy and security, some big things that we're proud of that we wanted to speak to was we recently were certified for SOC 1 Type 2 certification, which is, it's really important to us to ensure the comfort and safety of our customers. So it's another testament to that commitment, as well as I know it doesn't pertain to manufacturing as much, but in the automotive space, also got certified with TSAX certification, which is one of the foremost certs you can get within that industry. So we are committed to it, and we will continue to strive to prove that and to inspire that trust. I did see another question come in. Thank you again, Tom. Can the EMQX broker run on a Windows operating system?
And that is a no. We are we're primarily Linux based, run on Linux, also can run on Mac OS, but the reliability, the dependability that you'll get out of those Linux based systems, and is the reason why most of our web architecture, when you get into data center and data services, they're mostly Linux based, and so. But there is a caveat to that. You can run a virtual machine on on Windows if you insist, and be able to run the broker that way. But Linux and Mac OS.
Great. Thank you, Ernest. Thank you, Tom. And thank you, everyone who submitted questions today. Um, that was all that we had. I know we're at time now. So do want to say thank you to everyone for joining. Really
Thanks,
appreciate
Tom.
your time, and please do stay connected with us. Like Ernest said, we are putting out new material and content constantly. So um, please stay in touch.
Thanks to all that attended.
Thanks,
Talk to you
everybody.
next time.
Bye bye.